Mental math is, we want to be able to do this in our head, right? Using our rules. Now, one rule I didn't go over was the base 10 rule, okay? Remember how the square roots, when I take a square root of 4, right? It's equal to 2, right? But there's a hidden 2 right here. Remember? They don't put that here because we just think it's a square root. Whereas if we take a cubed root of 8, it's equal to 2 also, right? But there's a 3. We show the 3, but we don't show the 2. That's what happens with this base 10. Okay? So, the way we put it in the calculator, okay, is logs. You always see log on the calculator, okay? So let's show you real quick what I mean by that. So, right here it'll say log, okay? Log. And that's log base 10, okay? So, they don't, now some calculators will have log base B, and you'll be able to put in the base, okay? Very few, but some. So, that's the same idea, okay? We're mathematicians. We're lazy. We don't want to write things we don't have to write. Okay? So, what I want to do here is think about this in exponential form. In exponential form, what's the base? 2. What's the exponent? Yeah, no, not 1. It's unknown, right? We don't know it. Because this equals I don't know, right? So, it's unknown, but we know that it equals 1. So 2 to what power equals 1? What does x have to be? Has to be what? 0. So x has to be 0. Right? Any number to the 0 power is 1, right? So in this case, x has to be 0. So the log base 2 of 1 is equal to 0. Again, we come to our base rule. Log of 1, doesn't matter what the base is 0. Okay? Is this making sense? Right? So what we like to do when we're thinking about this in our head is think about it out of this context. Okay? Now, what's the base to this log? Unknown. No, it's known. But we don't write it. It's 10. So we like to think, okay, 10 to what power? 10 to some power is equal to 0.001. Well, what that means is that it's obviously a fraction, right? So if it's a fraction, that means this power has been flipped. If it's been flipped, that means x is negative, right? Now, how many thousandths, hundredths, or whatever this is? So you go, okay, 10, hundredths, 1,000, right? So how do I turn a 10 into 1,000? 10 times 10 is 100. 10 times 100 is 1,000. So it takes 3 tens, right? So I'm going to take 3 of those tens, but it's a negative 3. Okay? Negative meaning I flipped it to make it a fraction, right? And then at least I have 1 10 would give me 1/10. 2 tens would give me 1/100. 3 tens would give me 1/1000. Does that make sense? Okay? So x has to be negative 3. Mental math. Yay. Okay? Alright, this one, same thing. What's the base? 4. What's the exponent? Unknown. So what's it equal? 64. So 4 times what, times what, times what equals 64. So how many times do you times 4 to get 64? Well, 4 times 4 is 16, right? And 16 times 4 is 64. So how many 4s did it take? 3, right? 4 times 4 is 16. That's 2 times another 4. That's 3. 3 4s. Bam. It's easy. Okay? Uh-oh. The base is 0.3. 0.3 to some power is going to give me 100. Well, that's crazy talk. So 0.3 to some power is going to give me 100. How am I going to get 100 from 0.3? Because 3 times 3 is what? 9. So, I mean, obviously, x has to be negative, right? Because right now, you're talking about 3/10, right? And if it's x is negative, you'd be talking about 10 over 3, right? Okay? And now you got to multiply them so many times that you're going to get 100. Right? Well, I know if I do it once, twice, now it's 100 over 3, or over 9, sorry. Right? So how many times is it going to be to get 100?
2.
Not just 2.
Negative 2.
No, this one's a lot more difficult. In this aspect, let's think of it another way. Log of 100 divided by log of 0.3. Okay? Because when I think of it this way, now I have log base 100, or log base 10 of 100. So 10 to the 2, right? So that would be 2, right? So I know that this is equal to 2 over, now I'm thinking, okay, log base 10 of 0.3, well, 10 to some number is equal to 0.3. I got to figure out what 10 to some number equals 0.3 is. That's my biggest problem, though, right? 0.3 is 3/10, right? So how many times do I multiply 10 to get 3/10? So obviously by a negative, right? But, so, okay. So then I have 10 over 3. It still is not giving me that thing I want. Does that make sense? Okay? So, in this aspect, we look at it on the calculator. I have an idea that's going to be like somewhere between 2 and 3. But it's going to be a decimal. Doesn't seem to be like it's going to be nice. So if I take log of 100 and divide it by the log of 0.3, I get negative 3.824978. Well, mental math. Yay, that's going to be fun. Yeah. So at some point you're going to have to round it. Okay? So this, to me, was a terrible mental math problem because, I mean, the best I can do with it is come up with this. It's come up with 2 over the log of 0.3. Okay? Because mentally, I'm stuck at 0.3. Now, when I plug it in my calculator, I get negative, and we knew it was going to be negative, 3.824, so the 4 rounds up, or we could go 3 places, 8249, which this could be rounded off to a 5. So it's either round this off to a 5 or round this off to a 2, it doesn't matter. But it's, in other words, doing it mentally is not going to work for us. See how that works? I mean, it's gonna, you can kind of do it to an extent, but you're not gonna really be able to until you use a calculator. So that's bringing up the idea of must use a calculator on this stuff. Okay? A lot of these logs are going to need calculators. Some of it you can do mentally. A lot of it you're going to be using a calculator on. Alright, these last ones, domain and range. Well, they gave us the domain such that x is 2, -2, -1, 0, 1, 2, and 3. And they want the range. The range such that y is equal to, so when I plug in a -2 here, I can think about it mentally. What does -2 mean? That means it's flipped, right? 5 over 4 squared, which is 25 over 16. Okay? Then I've got, well, -1, that just means it's flipped, 5 over 4. 0 just means it's 1, right? Anything raised to 0 power. That's simple. 1, oh, that's just 4/5, right? 2, that means it's just 16 25ths, right? And 3, which means it's just 64 125. Okay? 19. Didn't even need a calculator. I could have done a calculator and you would have these big nasty numbers, right? Or you can do it mentally and just know what it's going to be. I would highly suggest doing it mentally with some of these because this gives you good practice at flipping it. Anytime you have a negative exponent, you're going to flip the fraction. And I need you guys to learn that because when we get that s back, I guarantee you they're going to give you some negative exponents. And it's going to be simple, man. I'm telling you. It's going to be like this. They're going to say, what is 4/5 to the -2? And you've got to come up with A, B, C, or D, right? And they're going to have A be 25 16ths and B be 16 25ths. And you're going to have to decide, is it A or B? You know what I'm saying? And half of you will be like, well, it's squared, so, and then they'll probably have one too that does this. So I would be sure that if I were writing the test, I would have A, 25 over 16, B, 16 over 25, C, -25 over 16, D, -16 over 25. And how many of you would choose D? Because, well, geez, it's negative and it's squared. So it must be negative squared, right? And that's what students do. I seen it happen yesterday when I was going over exponents. In this class, in pre-cal, okay? So, if it's happening with all my pre-cal students and it's happening in my Algebra 1 and Algebra 2 students and my geometry students, I'm sure it's happening with you guys, right? So, that's why we have to be able to choose A. We have to know that what happened is these got flipped and then they got squared. Does that make sense? Okay. So in this next aspect, we got, this is a D, right? This is R, such that Y equals. So remember, this is squared, but it's flipped and squared. So it's what? Somebody tell me. It's flipped and squared.
-9 over 60.
Close. What is it? Try again. It's not negative.
If it's squared,
Mm-hmm.
it's 16 over 9.
Yes. See, so if I take this and I flip it, right, it'd be 3 over 4 squared, which would be 9 over 16. Not negative.
I thought you said negative.
It is -2. -2 means that 4/3 to the -2 is equal to 3/4 to the 2. Right? All the negative does is flip it. All it does is flip it. So that's a good question. Okay? So even though I just said that here, we still didn't get it, right? We've got to be able to know that negatives just flip it. That's it. So then, in that case, what is -1? If it's just flipped. Anyways. What do you say? It's just flipped.
I just said.
What did you say?
I said 4 over 3. Alright, 3 over 4.
3 over 4. Okay? It's just flipped. It's just flipped. It's negative exponent. It's just flipped. Okay, to the 0 power. Come on, people. 1. Nice. We finally got the 1 down. Okay, what's to the 1? 4/3. Say no more. Okay, to the 2.
16
16
9.
ninths. To the 3. 64 27ths. Okay? Just 3 times 9 and 4 times 16. Okay? That's it. Well, we got one more problem for the home.